Today we're going to talk about storage for what's next. Okay, we have a packed agenda. Tom and I are going to alternate between the two of us, the different sessions. Both of us are very technical, so we had to fight over who's going to do the marketing stuff, and I lost, so I'll be doing the marketing stuff as well. But please feel free to ask questions whenever you want about anything you want. We're going to have, because we're alternating between the sessions, we'll leave enough time at the end of each session for open questions, but also in the end of the entire 90 minutes, we'll leave sufficient time for any questions that you forgot to ask. Regarding what Fred said about embargo, so this session we're talking about our vision, our future, what we see as the next storage platform. So everything is okay to take pictures, to tweet, whatever. When we get to the demo, I'll kindly ask you not to take pictures because this is something that we have yet to disclose outside publicly. Okay? Okay, so what we're going to do today, we're going to go through, is my screen blocking? No. Okay. Recap about Kaminario. I think that most of you are already familiar. We have done some briefings before, but just to get everyone on the same page. Market focus, what we see today as the focus for at least our market, what we are targeting as our customers, how we're winning today that market with our current generation. Then we'll talk about the requirements for the next, or the market requirements for the next platform. And Tom will talk about how we architect our product to fit those requirements. And of course, we'll do a demo in the end, questions and answers. Okay, so Kaminario at a glance. Kaminario, roughly 250 people worldwide, headquartered in Boston, Massachusetts, just outside of Boston, Needham, Massachusetts, R&D in Israel, and we have offices here in the UK, in London, Paris, and Seoul, South Korea. Our product is an all-flash array. Okay, we announced our 6th generation, or Gen 6 as we call it, back in February. We are a software company. Okay, so all the storage, all the patterns that we do is around software. Of course, we sell a single appliance with the software and hardware combined. However, everything we do is around software. Customers span global 2,000 enterprise with a large focus about SaaS and online businesses. I apologize in advance. I'm going to be saying SaaS a lot throughout this entire presentation. Partners, so here in Europe, 100%, and also moving to that model of 100% worldwide. Still venture-backed with $218 million to date from leading venture capitalists. Okay, so what do we do in Kaminario? We basically enable our customers to scale their business easily and cost efficiently. And how do we do that? We provide the backbone of flash infrastructure for the data center. Just to talk about our latest funding of $75 million back in January. So this fundraising also allows us to focus and to fuel efforts mainly around 4 different pillars. So the first one is to expand our sales and marketing efforts globally. So we have specifically in Europe, where we have already deployments, France, Germany, Poland, Armenia. And also in Asia, spanning installations within India, South Korea, Singapore. Did I miss anyone? China, small country, and Australia as well.
One question.
Yes.
What is the sum of the investments totally?
$218 million. 218. Yeah. So also, like I said before, channel driven. So just to expand on that channel strategy, so we have more scale of our go-to-market globally. Accelerate technology, ecosystem relationships. So the obvious suspects of Cisco, just finished Cisco Live yesterday, or today, what is it? Yeah, yesterday. Was a good presentation there as well. And so Cisco, Oracle, VMware, Microsoft, a bunch of those second-tier backup targets, Cohesity, Rubrik, to name a few, and of course small companies, tech companies such as Intel and Samsung as well. And I think what we're focusing here today is how we pursue very aggressively the long term with our innovation. Okay? Okay, so off to the market focus that we see at least. So the rise of as a service, okay? As a service, it becomes a very popular thing to say, but we actually see it as our target market as well. So SaaS specifically, if you look at those numbers, courtesy of IDC, we can see that the majority of the spending, this is projected to 2019, but $174 billion projected for as a service, with the majority of it with software as a service. And I think this shows us behind the numbers or behind that type of segmentation, there is a lot to discuss about how, in general, the storage market is behaving. We see a lot of data centers, a lot of customers that are choosing and are opting to move workloads to the cloud. So if I'll give the most simplest example of an Exchange server. Okay, if once you had to maintain your Exchange server and the storage for it and all the networking and all, now you can just move it to the public cloud, Office 365 or Google with their Office suite, and then you just consume those services as a service. Okay, you don't have it on-prem anymore. But that's a very simple example, but if we're looking about customers taking out healthcare, taking out fintech outside of their on-premises deployment, they're moving it outside what we see as the public cloud, but when we think about the public cloud, it's not necessarily your Amazons and your Azures. It could be still companies that just build their own private clouds and they're hosting their own products and solutions, and they're offering it on a as a service basis. So the as a service really spans across all the industries. We mentioned health tech and fintech as an example, but e-commerce, we see that a lot. Enterprise as a service, HPC also great example is just Siri on your iPhones. When you ask Siri something, it goes over to a voice recognition company, Nuance, that uses Kaminario as their infrastructure. Okay, so they use that. It comes up to their servers, runs on the Kaminario infrastructure, and then Siri understands what you're saying.
Can you go back to the previous slide?
Yeah, sure.
So in those numbers,
yeah.
If you cut out Amazon, Google, Azure,
yep.
Salesforce, don't know whether you would get into somebody like Salesforce. What's left out of those numbers, though, in terms of a market to sell into? Do they take the majority of that market, or are they only a small player in that market?
So, well, it's hard to call them a small player because that would be unfair, but the majority is still private clouds. The majority still do not move their production workloads to the cloud, specifically customers with great scale. We touch about this later on, why at large scale you won't find those customers running on those companies, Azure, AWS and Google Cloud.
But specifically your slide says public cloud software in that instance there. So if you look at software as a service, imagine you take out people like Salesforce and so on.
Yep.
And that leaves you a number of smaller providers who might choose not to build their own storage component for their offering.
Yep.
What percentage do you think that leaves when you take out all the big boys of those numbers? Because that's the market you've got left to go after.
Yeah, so those big boys, I would mostly categorize them as infrastructure as a service.
Right.
Okay. That still leaves 117 billion as software as a service, which is the full stack, okay, offered by also, AWS and Microsoft Azure still offer the full stack as a service products. Exchange is a good example of that. But if you talk about the infrastructure as a service, that's already covered.
I'm just trying to work out what size market you think you've got to go after in terms of your
so I can get back to you on the we did the analysis. I remember around 80%. Okay, 80% is not on the public cloud.
Okay, we can talk.
Yeah.
We don't have to, but just interesting to see what that market
that
size
pie
is.
looks like. Yes,
for, yeah.
I have a slide on that as well, but unfortunately not in this deck.
Sorry, just another question.
Yep.
That's public, and you mentioned the bulk of the scaling is in private. Where do you stand on hybrids?
On hybrid clouds. So hybrid clouds, it's an interesting question because we see a lot of companies that They would do hybrid clouds in the sense that some of their workloads they'll keep on premises, some of their workloads they'll move to the public cloud, but they'll be isolated. Okay, so you'd have maybe companies saying, okay, whatever's not core business, we'll move to the we'll move to the public cloud. If it's not revenue generating or it doesn't require the performance or the reliability, we'll move it to the public cloud.
Sorry, I meant to ask, how do you play in that?
How do we play in that? So if it's we sell an appliance, so we sell on-prem. Okay, so if a company is deciding, okay, we want to use Kaminario for our on-prem data center, but we also use the public cloud in the sense of a infrastructure as a service, so we don't play in that extension of their operation. Yeah. Okay, so I think we discussed this slide, talked about the different industries or different verticals where we see SaaS. It's practically all around us. Even a bank, if you think about a bank, you don't think of it, first thing that comes to mind, well, it's not as a service, right? But think about those new apps you have on your phone. This is all cloud scale applications that, in a sense, you're consuming some sort of online services, right? So also they need to build their infrastructure for that to be supporting that cloud scale type of applications. And let's take a good example about, and I think it touches your questions before, Chris. Let's look at a customer that we've met recently, and they were hosting their entire environment on the public cloud. Okay, and then they were very successful, so they scaled their business, added more users over and over, threefold the amount of users over 3 years. And now, all of a sudden, the public cloud is not good enough for them. Why? Because the scale of economics just doesn't work, okay? So they ended up with a very, very big monthly bill to AWS in this instance. And they found, okay, we need to go and build our own data center. Okay, so they built their own data center, and for that period of time, it was great. Cost went down, okay, because they were doing their own IT. So with all the overhead of managing IT, it still is more cost economics to do it on premises. And the performance went up, okay. Once you build a stack that it's we have the cattle and the pets kind of analogy. So once you build your data center to suit your own needs, as opposed to Amazon building the data center in the public cloud to fit the entire market, so the performance went up and it's tailored to their needs. But they were very successful, so they increased the number of users, they added more and more infrastructure, and then all of a sudden, costs went up, performance went down. And how come, right? Because again, this type of economics, they build a private cloud in the first place to allow for that type of scale, to gain the better cost structure and to get better performance. So it led just, trying to do a root cause analysis of that. So it was a choice of the storage infrastructure for that private cloud. So if you don't make the right decisions to begin with, okay, and you're very successful as a company, you might end up spending a lot of money on your private cloud implementation, and also the end user is not very happy about that.
Can I just add one little comment to that? And
yeah.
That's a one-dimensional view that looks at cost. If you're looking at public
and performance.
And performance.
Yeah.
But if you're looking at public cloud, one of the things that you have there is innovation.
Okay.
So Amazon said this week that they came out with like 1,000 new features in their environment last year.
Yep.
I don't think an individual enterprise can innovate to the same degree, and I'm not sure how they would add that into their cost structure that says the cost of innovation compared to using a public cloud could be worthwhile staying in the public cloud, even though it's more expensive from a technology perspective.
So I agree that, think about Amazon innovating with, like you said, 1,000 new features, right? But they're targeting those 1,000 new features for all of their customers. Okay. Now let's try and filter it down to the amount of features that are relevant for this specific customer.
Yeah.
So I don't know, maybe 1%, maybe not, maybe more, 10% even. That's great innovation. But if they're going after storage platforms that is dedicated for the private cloud and to power those private cloud implementations, you might get that type of innovation as well.
Yeah, but
from a software company such as.
I was just going to say, my point is
yeah.
that the fact that they would then be relying on you to drive that innovation for them in certain components.
Yeah.
Because you would be their provider in that scenario. So therefore, if they are making a choice to come to somebody like you, you need
Yeah.
to be showing significant
Innovation.
to something that matches what the public cloud is doing.
Yeah, I agree. And we're working closely with public cloud providers as well. So, partnering with them so we can also get that type, but also working with customers to understand when they move, and we'll talk about that soon, because there are a lot of things in the public cloud that we want to take over. Simplicity is just one of them. Okay, any more questions around here?
Maybe I can just make a little comment
Yeah,
on that,
sure,
shall I?
sure.
So I meet a lot of customers, and it may be to do with the particular customers that I meet, but almost, and it's maybe a question for you guys, almost all the customers I meet have some element of their environment in the cloud nowadays, and very rarely, I think I've only met one, maybe two, are happy with the predictability or the levels of the bills that they see coming for their cloud usage. And one of the examples of the happy customer was an environment that ran schools, and they were able to turn the systems off when they weren't in full operation. So I guess the level of improvement can be very significant in the cost basis if the cost of the infrastructure is paid for in just a few quarters worth of cost for the public cloud. The level of difference in the cost can be huge for what we see meeting customers.
I would say that that's a discussion we could spend the rest of the day on.
Yeah.
So perhaps that's a good one to talk
Maybe
about
later.
over a drink later. But
Okay.
because there's so many different ways you could cut that discussion.
For sure. Okay, so what are the basic requirements for that SaaS storage infrastructure that we at least see with our customers, and that customers expect to gain? Like simplicity is just one of those pillars from those public cloud vendors, but to have it on-prem. So real-time analytics, okay, no one is doing only their production OLTP, online transaction processing on their side. They're doing much more than that. They want to get insights, they want to get as much as they can from their data, and they want it now. They don't want reports for the weekend, they want it within the hour. Sub-millisecond latency is a must. We're talking about, this is I know Tom doesn't like this term, but Americans call it table stakes, right? I mean, you can't start talking about customers, oh yeah, I'll give you 10 millisecond latency. That's just not acceptable anymore. Mixed workloads are the norm. I think it really ties back to analytics. We want to run the analytics and the production on the same platform. To have siloed environments for production and for analytics it just doesn't work. You want to have the most recent data at all times. Agility, to match the agility of the apps. We keep innovating the storage infrastructure, but we have to remember who we're serving. We're serving those cloud scale applications. In that sense, we need to remember that scalability is fundamental in this case.
So
Right?
could I respectfully say that looks like a block storage diagram rather than, say, an object storage diagram or a archive diagram or a description of the data that somebody would be storing?
I agree.
Because sub-millisecond latency doesn't quite necessarily have to apply to all object environments
I
or
agree.
archive environments. So is that deliberate? Are you
That's deliberate because we're not trying to play in that realm of archive.
But
That's
in terms of a SaaS storage infrastructure, lots of people are going to Amazon because S3 gives them a SaaS opportunity where they can buy that as an on-demand solution. They don't have to care what's underneath it. But it doesn't necessarily matter that it's sub 1 millisecond latency.
yeah, no, I definitely agree. This is targeting production. This is targeting the e-commerce that are going online to the website, and they want to click and say, I want to buy this, and they want a very responsive back end to deliver that. Not going into Glacier or stuff like that. We're not competing.
It's not just archive, though. Increasingly, object is being used for audit reasons, for that capability of using a global namespace, which allows people to say, yes, we know exactly what's happening with this information asset that we have.
I agree.
So
There's also room for very fast flash-based object storage. We're not saying it doesn't, but we're in the business of block. This is our forte, and this is where we're focusing our current efforts.
What are the real-time analytics of?
Of the
Because I associate real-time analytics, say, with real-time Hadoop style analytics of data warehouse type collections of
Yeah.
data, but I dare say you're not talking about
No, so let's say you have your production workloads, your online transactional processing,
that.
and it's going through, it's 24/7, right? And then you want at any given time to take a snapshot of that environment and to run an analytic workload to see if whatever campaign you're running at the moment is successful or not. Okay, so that would be done without starting to move it to a different designated environment that can run maybe analytics like after, give you a result after a day, after you migrated and you stream down all the information to that specific environment. So we're trying to say we're going to consolidate and give the ability to serve that type of responsiveness and that type of SLA also to the analytics. Okay. With that, I'm going to hand over the baton to Tom.
Thank you, Shai. So, good morning, everybody. I'm Tom, and I get to talk to you about the technical stuff today, which I prefer, which is good. And first of all, I'm going to cover just a recap on the current product that we're selling today successfully, and it allows us to compete successfully with the other all-flash vendors that we see. And I know that because our favourite way of selling is to get customers to try the system, to do POCs against all the major competitors that we see. So I'm just going to cover what the current product looks like and how that leads us forward to the future. So we have, of course, a fully software-defined architecture that allows us to take advantage of the latest hardware as it becomes available. We're using the latest generation flash media from our partner at the moment, from Samsung, the 48-layer 3D TLC NAND, and we deliver it as a platform. So we deliver a hardware and software platform which our customers use to provide block-level storage. And that platform runs our software, all our intellectual property is in our software, all the clever stuff's done in our software. And we're currently on version 6 of the Vision OS software, and it matches with the generation 6 of our hardware platform. Something that's very nice and not always true, in fact very rarely true from storage array vendors, is that we can intermix in the same system the different hardware components. So we've got our generation 5 hardware can be part of the same flash array as our generation 6 hardware, so the controllers intermix, and the latest version of our Vision OS also runs on the older generation of our hardware.
How far does that go back, Tom? Because obviously, like say, Fibre Channel will allow you to go back a couple of generations, and
Yes.
tape you can go back a few generations. LTO, how far can you really push that?
So there was a significant change between generation 4 and 5.
Yep.
So at the moment, the 5 and the 6, but we also make commitments about the future as well.
Right.
Okay.
And then how far will you go on that? Would you allow, if 5 was the starting point of the next generation,
Yep.
and you've got 6, would you allow -2, -4?
-2. So n+2 or n-2, depending
-2.
where you're standing.
Right. Okay.
What hardware platform are you running on? Is it standard Intel, Xeon type?
Yes. The standard Intel
Yeah.
controllers. I'll show you in a moment the different layers of the stack. We have all the data services that you would expect from an all-flash array, from a modern all-flash array. The data reduction, the protection layers, the management layers, the integration, the API integration to manage the systems, and the connectivity to the open standards like OpenStack, Docker, Flocker. And it's Cisco Live, we announced the integration with UCS Director. And we have Clarity, which is our web-based analytics platform, which lets you manage multiple systems, view the real-time data about how they're performing, and make suggestions about how you may want to use things differently. So to analyze the data and keep long-term performance information about your environment. So the hardware platform is all backed by our commitment, and the commitment partly is around the commitment for future compatibility, but we were I think we were the first all-flash vendor to make a commitment, a no-quibble commitment about how much of your end user data you can fit in our system, so the capacity guarantee. And we were pleased to see our competitors have reciprocated partially, and they also now make commitments, but we've extended our guarantees as a part of our foresight program around availability and performance, and everybody will talk to you about availability and performance of all flash arrays. Very few companies will commit with financial penalties around the availability and around the performance level they'll provide and the amount of actual real data you'll fit into the system. There are only one sensible caveat we make around the capacity, that we will guarantee what you'll fit into our system so long as the data is not pre-compressed or pre-encrypted, for fairly obvious reasons.
Can you not compress encrypted data, because many other systems seem to be able to?
We could, and we can also compress data as well, but then not in the same level that at our wide guarantee. So we would see on an Oracle database that has been pre-compressed, we could see up to 1.5 or even 1.8 compression level on top of that as well, which is less than what we guarantee widely, which is 4 to 1.
Okay. So we make some other commitments as part of the Foresight program. We commit to the compatibility between the different generations of the hardware and the software. We commit fairly uniquely that the support costs will remain static throughout the life of the system. There's no hockey stick bathtub curve, because the reason that storage array vendors traditionally have increased the costs after years 4, 5, 6, partly to move you to a new platform, partly because disk drives have a very bathtub curve failure rate, whereas flash media is different.
So just on that one, do I have to commit to a certain length of time to get that value, or can I say after 3 years I'm going to continue using this platform and you keep the costs the same?
We commit to keeping the costs the same. There will be end of life periods where we can no longer support them when we can't get spares.
Yeah, but
anymore.
what I mean is, do I have to buy 6 years up front to get the flat cost, or can I buy 3 years up front and extend for 3 years and still keep that flat cost?
You can buy 3 and 3.
So you're not tied into
No.
committing for a longer period in order to get the savings.
No.
Okay.
And the final one, of course, is that the SSD-ware is covered by the support for the life of the system. So long as you've got a support contract and you're using it, we'll continue replacing the media regardless of the workload that you put on there. Okay. So what does the system look like? How is it built? What are the building blocks? What's putting it together? As you asked a moment ago, we have some controller nodes, standard Intel-based controller nodes. We call them K nodes because they're Kaminario nodes. And a standard building block, you have 2 of them. They are talking to media, the flash media in today's product, with SAS, 12 gig SAS connectivity. They're talking to the outside world. The block level access is via fibre channel or iSCSI today, and that's either it's generation 6 fibre channel, so 1632 gig and 25 gig Ethernet. Very importantly, they're interconnected with RDMA InfiniBand, very low latency connection to allow them to talk to each other, and that enables us to be fully active between the 2 nodes. And we can support on a single K block 4 shelves of media. On a single K block configuration like this with 4 shelves, it takes 10 U of rack space. And we can commit to containing a petabyte or 960 terabytes of data within that single K-block configuration with today's media sizes. But you can, of course, put future types of media in there when we add support for them as they become cost efficient. And you can mix and match the media you have in the system. Sorry, did you need that one? Okay. So if we look at a single K block, if we have a single configuration like this, it's not hugely different from a number of other all-flash vendors, with the exception that a lot of them are still active-passive between the nodes, whereas ours are true active-active. All the connectivity, all the volumes are equally accessible on both, and the workload is equally spread on both. But of course, because we're Kaminario, most of you guys already know that we can alternatively scale out the system by adding more performance, by adding more controller nodes. And when we add more controllers, we expand the InfiniBand connection between the nodes so that they can all talk to each other equally. So we get that very low latency RDMA connectivity between them, and it makes no difference which node you talk to. All the heavy processing, all the compression, the deduplication, all the replication is split equally and distributed equally amongst the nodes. So it's true active-active. It's not active-active ALUA with some paths preferred. It's true balanced active-active, and we can scale on today's system all the way up to having 8 controllers. So scale out for me is becoming increasingly important. I think you guys will probably agree.
What type of topology is that? So how many hops between, for example, as you grow out, how do they connect?
It's never more than one hop. So it's the InfiniBand, as we scale out, has a pair of redundant InfiniBand switches, so all the nodes talk to each other equally.
And what's the limit of scale?
So the limit of scale today, very good question, is 8 controllers.
As a product that we sell at the moment, it's 8. At the lab, we've done more than that. Up to we occupied the entire InfiniBand switch. We can go even further than that with larger InfiniBand switches. But I think that the sweet spot where we see customers saying, okay, and it's going to tie back to what we're going to say about the future, is that once they reach a certain scale, they're saying, okay, that's enough for this environment that I have now. I want another one for my other environment. So 4 would be the sweet spot. We didn't see any customers asking for more as far as scale out. Scale up is something that they ask more because as they bring more and more environments, the performance suddenly doesn't become the bottleneck, the capacity is. And that's why we have the ability to add more drive shells to those existing.
So just go back and say that again. So you, in terms of what people typically buy, you were saying 4K blocks?
No, I would say the maximum would be a 4K block.
So what are people typically buying then?
So we have, it depends on the environment. We have customers that buy only units of what we call a quad system, and our marketing people, made a strategic mistake when we called it a quad system because it had 8 controllers.
Right.
And they say, well, I don't want the system with 4 controllers, I want 8. A quad has 8 controllers, and we have people that buy quad systems as a unit, fully scaled, and then they buy another one and another one and another one. And that leads us quite nicely into our future vision, which we'll talk about later.
But the reason I was asking the question, Tom, is because when you're buying technology of that size, there is not a technical, but more often an operational limitation that says I don't want to put more than a certain amount in a certain infrastructure because if I have to upgrade it, maintain it, move it, everything I have to do is restricted when I go to things like change control to get any changes or do anything with the environment. So usually, even though you might support more, customers tend to stop slightly lower than that. So because
you're right. We have a lot of customers that start with a single K block. What's very nice is that almost all our customers expand their systems. A very high proportion come back and buy more, which is nice for us. A lot of people start with a dual and expand it. We have some customers that like the quad systems, and we have other customers that are pushing us hard to support more than the quad system.
Right.
But then it's a case of balancing failure domains, mean time between failures, and the number of devices you have in a single system becomes counterproductive after a while. So it is a balancing point, but at the moment the sweet spot is 4.
Using Mellanox for InfiniBand?
Yes.
Yes.
And you're using SAS, you've got those for NVMe when it comes up and replaces SAS?
Yes. So this is where we
have a slide on that one.
We have quite a few slides on that one.
Good, thank you.
We're getting there.
Okay.
But for us, the ability to scale out is very important today and increasingly important. I guess we're all people that work in storage, and it's very exciting times in storage, not just because over the last decade we've seen the evolution and the becoming mainstream of flash media, which is, somewhere between 10 and 100 times faster than disk, but also becoming available are things like ZNAND and Crosspoint, which is another order of magnitude faster again. So whereas it used to be the case when I was at EMC, you'd have big symmetrics with 10,000 disk drives being managed by a very small number of processors. Today, you're seeing some vendors building systems with 3 flash drives per controller. So you can exhaust controllers very quickly with a small number of pieces of media. So having the ability to balance the amount of compute in a system with the amount of flash media to match a customer's requirement is becoming increasingly important, and it will become even more important as the new flash or new types of media become cost efficient, like Crosspoint and like ZNAND. So there are many different people that do scale out, and many people will tell you that they do scale out, but there are some limitations that are quite easy to see with a lot of the implementations. And in my mind, a lot of the limitations you see from competitive systems come around from not having the very low latency interconnect. So if you deploy a system with a 10 gig Ethernet backbone or scale out using the customer's network that's not able to support RDMA, then it's no longer efficient. You can't get good performance to distribute all the I/O across all the nodes equally. So you'll see a lot of the systems that, although they support scale out, they'll only do it in pairs. So any particular volumes are only available in this pair of nodes or this pair of nodes. And that's the normal way. And really, that's not true scale out. If you don't have proper distribution of all the workload and a proper global dedupe pool across all your media, you're not getting the full benefits of scale out. So Kaminario do provide all those features. So our dedupe is global across the entire capacity in a single array. Replication goes through all the controllers. The compression workload is split equally. The dedupe workload, even for individual volumes, is split equally across all the nodes. Okay, so I've mentioned briefly Gen 6. Gen 6 we launched in January this year. February. And it's deployed successfully at a lot of our customers now. And Gen 6 brought us right up to date and ahead of most of the competition. We support the Generation 6 fibre channel, which goes all the way to 32 gig connectivity. We have the slots ready. We haven't put the Crosspoint in yet because it's not cost efficient for us to do so, but it's ready to take it, the front-loading NVMe slots. We have the hardware-based compression offload, which I'll go into a little bit more detail about in a moment. We have the system ready for the NV DIMMs, and it's built to take advantage of the NVMe fabric work that we're doing that we're going to tell you more about today.
So a lot of the focus which we've seen is for Crosspoint, NVDIMM, NVMe to be server-side, and then it's how do you actually deal with server-side to storage array management.
Yes.
Is this looking at, because you've got loads of Xeons in there, are you going to be going hyper-converged rather than converged sometime in the future where you will be actually saying, yeah, give us the workloads, we can manage all of that?
So I guess it's just a matter of exposing the right APIs, and then soon us being software defined, and we do have it as a future. Wouldn't call it feature, but a future idea of taking our software, telling the customer, saying, hey, this is what we need as far as x86 resources. That's the amount of DRAM, that's the amount of CPU power that we need. Those are the APIs that you're going to get, and now you can expose them to whatever application that you need. And then it's kind of saying yes, but it's not a yes to hyperconvergence, but not in the current terms of hyperconverged systems today that we see that everything is bundled up together, very very tightly coupled. But we'll be able to expose through APIs and just like microservices of if it's the dedupe compression engines or whatnot, and add on top of that whatever application that is running. Yep.
Okay. So that's Gen 6, the hardware platform that we have today, and that can build into quite a significant system. So this is a fully populated quad system, so 8 controllers. It fits very conveniently into a 42U rack, And once it's in fully populated 42U rack, we have 384 SSDs. We have 16 of the 16 gig or 32 gig fibre channel ports, or the 25 gig iSCSI ports. So more connectivity than almost any workload can drive, and that translates into a very significant amount of capacity. So before any data reduction, if you filled it full of encrypted data, we'd get 960 terabytes of usable capacity out of the system. But if your data is not compressed or encrypted, we'll fit 4 petabytes of data on there, and significant levels of performance, 25 gigabytes a second of throughput. So that's Gen 6, a fully scaled Gen 6 with today's supported drive sizes, and today we're supporting the 4 terabyte 48 layer 3D TLC NAND from Samsung, because that's the most sensible option. We will release support for larger drives as they become cost efficient. It's not cost efficient to do so when they're more than twice the price.
So Tom, on your little figure there, you show 1.5 million IOPS
Yes.
for 384 drives, did you say?
Yes.
If those drives are all doing 100,000 IOPS, or 100,000 IOPS capable,
Yes.
you would have a huge, 38 million IOPS compared to
Yes.
1.5 million IOPS capacity. You've lost a huge amount there, obviously, because of various features that go on within the array. How much of that is down to the architecture and the way you're doing things, and how much will of that will change when you move towards an NVMe architecture?
I agree totally. And at the moment, on pretty much any storage array, the controllers become the bottleneck, and it's why having a scale-out architecture is very critical. So if you take the configuration here, it's not unusual for customers to come to us and want to deploy a quad system with 1 shelf of media per unit to get the maximum performance, but they don't need the capacity. So thank you for that. I fully agree, and that's hopefully we'll cover some of that.
Yep.
Did you think of trying to improve the design of the controller to alleviate the bottleneck?
So yes, it's a balancing point. There's a different approach you can take to put much more compute power within a single controller, and you could easily spend 4, 5, 6 times as much money on a single controller, but the level of performance improvement is not linear if you scale by adding more and more compute in the controller. Whereas when we scale from 1 to 2 K blocks, the performance improvement is slightly better than linear because of the way the algorithms work. And when we scale from 2 to 3 or 2 to 4, it's slightly better than linear performance increase. So it's more cost efficient to scale out than it is to replace controllers with faster CPUs with more DRAM. Does that make sense?
But also we do recognize that on top of that commodity hardware curve, we do find that some components would be more hardware storage optimized. I think Tom is going to talk about that regarding compression as a good example of how we do optimize the commodity hardware to be more to work better for our needs of a storage subsystem.
Do you do any in-RAM stuff at all?
In RAM,
Yeah.
so we do. You talk about like dedupe and stuff
Or
like
even
that.
just being able to run certain workloads pinned into RAM rather than relying on disk and having lazy writes later.
Yes, so that's part of the architecture. So
can you pin them? So like Oracle will have a in-RAM database and they actually have the database running in RAM. Can you do similar things in the arrays?
we did in previous generations. Kaminario started out actually as a DRAM appliance, but those, we found that market to be rather niche. And then with the rise of standard SSDs, we found that to be more appealing to the general market. That's one thing. The second thing is anywhere you go, a write will always be acknowledged and mirrored into 2 DRAM, discrete DRAM.
Buffers.
What?
Buffers.
Yeah, write buffers, that's the right term. So it will always be served from DRAM anyway. So that's, so we don't see much of a value to add on top of that a discrete pool, because that's already automatically done within the architecture.
Do you have a first attack with flexible style arrangement with any server vendor?
So we actually, with Cisco, we have, we've been through all the qualifications and certification process of the entire stack of components, be it switches and the UCS connector, which we announced now in Cisco Live, and also the UCS platform is certified as well. And then we have customers running, without the brand of some sort of FlexPod or flash stack. So
That's a no then.
that's a no. That's a no. Yeah.
Okay. So we've been talking a little bit about data reduction. Data reduction for production workloads, I think, is very important because it enables you to make best use of what the most expensive part of any storage infrastructure, which today is still the flash media. Flash media prices have been reducing up until some point last year, but they're still by far the most significant component of most storage arrays. I'm seeing a questioning there. No. Okay, good. So the storage is very expensive. We do what we think is a very extensive and very sophisticated level of data reduction, including dedupe, which very importantly for production workloads you can turn off. So there are data sets, for example, Oracle databases, that because they have a unique sequence number at the beginning and end of every block will never dedupe. So we do provide you the ability to turn dedupe off for specific volumes. If you have some encrypted data, for example, there's limited point of deduping. We do compression, and I'll go into a little bit more detail about what we do today with the compression in a moment, and of course bin provisioning. So we have a nice marketing graphic of showing what that means in real life. So we're taking out the duplicate Lego blocks, we're squashing them, and we're removing the gaps in between. So this all helps to be more cost efficient. Now, you guys are a very technical audience, so we wanted to go into a little bit of detail about the compression and encryption. We have a partnership or a collaboration with a leading microprocessor manufacturer vendor to do our compression offload with our Gen6 hardware platform, and that allows us to do two things. It allows us to ingest data more quickly, a higher rate of throughput, but also to be more aggressive with the compression algorithms that we use. So it's done on microprocessors on cards in the front of the controllers, so the workload is still distributed amongst all the controllers. We use a more aggressive version of the LZ77 algorithm than in older generations that includes the adaptive Huffman encoding, and that gives us something like a 30-35% better rate of compression and allows us to increase the rate at which we ingest the writes into the system. Okay. So a couple of more techie details that I thought I'd include. So there are two very good reasons that we managed to do excellent scale out, one of which is having the RDMA based very low latency interconnect, and the other is the way that we deal with the metadata. When you get to very large capacities of data, the metadata itself becomes very large and difficult to deal with. So we do a number of things to optimize how we can deal with the metadata. For example, the dedupe tables are distributed amongst all the nodes, and that's not to say that each node has a full copy of the dedupe data, because that would take too much DRAM. Each node has a portion of the dedupe table, which allows us to be much more efficient, and we have the low latency interconnect to do the checks on whether there are hits or misses. And the same for the mappings of the address space. That's all distributed through all the nodes that allow us to scale very well. When we're doing the dedupe calculation, differing from some of people's approach, we deliberately use a weak hash. So statistically, we're going to get hash collisions, which means that you get two hashes created for the same block of data. But we expect that, and every time we think we've found a unique block of data, we'll go and, or we think we found a match, we think we found a match to a block of data that we've seen before, we'll go and reread the original block to make sure it is a true match and not a hash collision.
So you're doing that in software? That we read and compare.
Yes.
Because that's what 3-part did, but they DG algorithm, but they were able to obviously do the comparing in the ASIC, which made it a little quicker to do that compare when you had a collision.
We have some cool stuff going on in the software,
Right.
all kind of filters that allow us to very highly optimize when we need to do the compare itself, and also the comparison is also pretty
Right, so
pretty
you're not,
quick.
You're not doing it every single time. You do it when you think you need to do it.
Yeah.
rather than- Okay. And how much in terms of performance is a weak hash calculation giving you than an accurate one?
But the weak hash reduces the amount of CPU, but has a much more significant reduction in the amount of memory you need to keep the hash tables. So it's, 20% the size of a 256-bit hash. And some customers, although theoretically the risk of a hash collision on a strong hash, you're talking about grains of sand on the beach type. For some banks and other organisations, they're not willing to have any level of risk of corruption. They much prefer to have the checking each time. And as on flash, reads are very cheap in terms of performance, so it's not a huge overhead.
And also, this means that we don't have to store all of the metadata in DRAM to get that type of calculations. So we're not also bounded by the capacity of the drives. So we see some vendors still limited by the capacity of the drives that they have to use, while we can still grow the usage.
I'm a little bit conscious on time, so
You can skip this one.
all these technical details, I've really gone into quite a bit of technical detail. They're designed to deliver predictable high performance in a way that requires as little tuning as possible from the system, from the administrators. As you get to thousands of volumes and petabytes of capacity, the ability for individual administrators to make specific optimizations for specific volumes is reduced. So another thing that we do in the software layer is we have the adaptive block size, and this is not just that we look for variable size digit matches, although we do. It's different layers right through the stack. We optimize to balance and to perform equally well for large block size and high bandwidth transfers, and also for small IOPS, small rates of fast IOPS, and to balance the differing requirements of them. And that goes right through from the balancing of front-end performance on the ports to how we lay the data out on the media. We keep logically close blocks together, even if they're dealt with as small transfers. And this gives us a very optimized, low latency, consistent for different types of workload. Okay. So just to cover off the other data management features we have, of course we have data at rest encryption that's certified. We have space-efficient snapshots that you can take many of very, very quickly. And we have our own easy-to-use replication between different K2 systems. And we have some very good integration layers with the different major vendors. And we have many customers using all these different types of environments. And we do the work to stay up to date with the different certifications. We announced the one with Cisco today, and we've got a big list of all the different partnerships we have, and we spend considerable effort to make sure that we're supported with things like IBM SVC, and you guys have got Data Core coming in later. We've got quite a few deployments in, I don't know if they're public reference, they probably are, but we've got quite a few joint deployments with Data Core as well. So I've covered quite a few of the things that we've got on the slide here. I realise we've not covered everything. We've got limited time and we want to focus quite a bit today on the future-looking products, but hopefully you see we've got quite a comprehensive set of services. I'm going to pass back to you at this point.
Thank you. And so I'm going to really do this a bit quick so we can have a sufficient time for the demo and for Tom's presentation about the architecture. So a bit of evolution or a bit of history of what we've seen with all-flash array industry. We coined the term 1.0 for those first appliances that really targeted those niche workloads, but no data services whatsoever, just speeds and feeds. AFA 2.0, emergence of data reduction features. You could scale perhaps, maybe scale up, maybe scale out, definitely not both of them. And then you would be targeting maybe VDI with the data reduction, or maybe some consolidation of databases. AFA 3.0 is already a full-fledged feature set, scale out and scale up, mixed workloads, consolidation, cost efficiency, very, very easy to purchase. And this is for the cloud infrastructure. And this is obviously where K2 Gen 6 is at the moment. But what's next? So we talked about before, there's some storage paradigms that we would like to take the best of breed of features from them. Hyperconvergent infrastructure as a service, or the public cloud, in the same category when it comes to simplicity and operational efficiency. So if you think about, a robo, just a remote office that, they have a very small data footprint and they use hyperconverged appliance, it's much easier, they have everything condensed into a single appliance, very easy to deploy and to maintain. With infrastructure as a service, you go into AWS and you just, I need 4 machines, I need 100 machines, very easy to purchase as far as the simplicity is concerned, to set up and to spawn up a whole full-fledged environment. But when you look at the shared scale-out storage array networks, the SAN, so you have the performance and the efficiency at scale. You remember we talked about those customers coming back from the cloud, and now the performance is tuned to their requirements, and the efficiency of scale, if built right, they can still scale as much as they want and still maintain better cost structure. So we want to take those 2 paradigms or 3 paradigms and to combine it into saying, okay, we want the economics of commodity hardware, but with a software-defined storage. Scalability of the cloud is must, to offer the same scale of deployments. The density and the capacity efficiency must meet those of all flash arrays today. Otherwise, like we said, the bills will go up. And hyperconverged appliances and infrastructure, they have very good operational simplicity, just have a single appliance to manage. So everything we build, or everything we're thinking of building, has to match, of course, the client, or the customer in this case. That's this cloud scale applications. So the growth, the analytics, and the dynamic attribute of those environments have to be supported by infrastructure that can continue to scale. So this is just saying what are the key success factors. I'm running through this just because I want to have enough time for the real technical discussion. If you want to take a picture, that's fine. Yep. Okay, so what is a software-defined architecture? What does it have to support? So we have to take advantage of those advances of the technological giants, technology giants. Okay, Intel, it's very easy to talk about Intel as the driver of the server market, but not only Intel, but also the networking and the media. Robust data services, I think what Tom presented, in the end of the day, you can try and look at it as a very hardened software stack with data services, both on the front of data reduction, but also the front of data services such as snapshots and replication. On top of that, you want an orchestration layer because you want to be able to compose all that storage. When you're talking about private cloud, you want to be able to compose that storage into different environments very easily with a dedicated orchestration layer. And again, regarding the question of optimizing the hardware, the compression is a good example of that. We have commodity, but we have the able to give it an edge with optimization that are more relevant to the hardware, to the storage subsystems. Okay, Tom, you're up next.
Right. I'm very conscious that we want to leave time for Shai's demo, because the demo is the best bit. So I will not spend too long on the technical detail, but just to say our vision is that you need to have a number of key things in your storage, any storage array for the future, whether it's deploying services for SaaS or cloud or whoever is using it. You have to have the modern storage platform like the K2. You have to have the software-defined approach to take advantage of the latest benefits of hardware, and you have to take advantage of the new protocols that get rid of a lot of the limits that we've seen historically. So, if we look at the modern storage platform. I've spoken already at too much length around K2 that we have today, but I've told you that we have some very good performance, some very good scale and some very good cost efficiency. So what are the possible problems? What are the things that we could want to improve on the system that we have today that we're successfully selling to a lot of customers? And there's some of the things that came out in the discussion that we had around what happens when we have these large customers. We have customers with many tens of K blocks deployed, and what issues do they have, and what are the things they want us to improve. So if we look at the limitations they talk to us about, and they're the same things that Chris was mentioning earlier, the need to decide where your fault domain wants to be, how many controllers, how many modules in each array, and having to decide that when you deploy it. You need to isolate specific workloads from other workloads. You need to be cognizant of the failure domain and where if you're having too many units in a single unit, the mean time between failure becomes significant. So that has some implications. If you have a system or a set of systems that you make the wrong decisions, when you do the purchasing cycle, the deployment cycle, your utilization overall over the whole environment goes down. And you can't share the resources between the discrete arrays. And as you get more and more systems to manage, no matter how simple our system environment is and how good our web-based management platform is, the complexity to manage it goes up as you increase the scale. So if we look at our vision of how we solve these problems, first of all, it relies on making use of our existing architectural software vision. So the same software stack that we're currently utilising can easily move to our new generation of hardware, and we're able to do it because of the architecture we've got today, providing future compatibility or forward-looking compatibility, and make use of all the data services that we already have deployed. We can still utilise our guarantee program and the web-based analytic program, as you'll see in a moment. And very importantly, this is where we get to the exciting stuff. So not only as storage people have we had the exciting of the last decade with Flash to new media, Crosspoint, we've also got the new protocols, so NVMe and NVMe over Fabrics. So most of you people in the room know about NVMe, and it's a new version or new way of talking to storage that takes out all the legacy SCSI-based commands that have existed for a long time, and it can run talking to native drives in servers. The NVMe SSDs have been around and in servers for a while, and they provide a performance improvement. But there's also the option of running NVMe over networks, NVMe over Fabrics, and it can run over a number of different types of network, and they can be Ethernet based, InfiniBand. There is also the possibility to run NVMe over fibre channel. So customers that have a large stake or large deployment of fibre channel infrastructure have the option, and there are already drivers available to do NVMe over fibre channel. But for us, probably the long-term future of NVMe over Fabrics is based around Ethernet, and probably over Rocky networks, because it has the same advantages that we have on our current InfiniBand backend of being able to do RDMA-based transfer, so very low latency, direct copies from controller to controller or from host to storage. And this allows you to get past a lot of the limitations of legacy SCSI-based connectivity. You can queue many more things, you can have lower latency, and I suspect a lot of you in this room have seen a slide similar to this one before. So having the NVMe protocol on the media itself provides a modest improvement in the latencies for single transfers. It provides more significant improvement for the number of things you can do at a given time. It doesn't provide anything like the level of improvement you can get from moving from Flash to Crosspoint or Flash to Xenon. So there is incremental improvements you can get in a storage array or storage device just by changing the media. But for us, that's not the most exciting thing. NVMe SSD is faster than regular SSD, but at an increased cost point. So there is a modest improvement you can get from NVMe, but not revolutionary. So,
is it also likely to? Are you also expecting improvements outside the simple performance?
Yes.
Not just fast.
yes,
Are you going to go into that?
yes.
We're going to demo
That's
it.
very much the focus. We believe there's far more significant improvements to be had, not from the performance improvement of NVMe, but the things it allows you to do architecturally.
Yeah.
Okay. So, a lot of other people are already putting the more expensive NVMe media and getting that incremental improvement. But really, if your bottleneck is still the controller on the storage array, then paying the extra money for NVMe connected media in the system can be limited benefit. There are people that have built bare metal systems based around NVMe that get you screaming levels of performance, but without the data services that most production workloads want to see. We believe the best use of NVMe and NVMe fabrics is to produce what we're calling a true disaggregation model, so truly separating the storage and the compute. And I'll show you a little bit about what that looks like. But if we just do a little bit more about the technology on this picture, sorry?
5 minutes.
5 minutes till you're, okay. So on the technology we have controllers, and just to be clear, we have NVMe connectivity on the back end over Ethernet, so NVMe over fabrics, and also NVMe connectivity from the hosts to the controllers. Now, there's been some good discussion recently about some of the limitations of using NVMe over fabrics between the hosts and the controllers, and there are some things, some application layers that will struggle. So within the NVMe fabric protocol itself, it includes definitions for multipathing, it includes definitions for multiple hosts talking to single devices and vice versa. But some application level things like clustering, like VMFS, require SCSI reservations, SCSI protocols to function for multiple hosts talking to the same storage at the same time. So until such time that all host applications that need to access the same storage fully support NVMe, and it's already supported by some clustering like Oracle RAC, like Clusterware, like there's a variety of them that don't need to have those SCSI level protocols for sharing. We suspect there'll be some customers that want to have iSCSI on the front end. And that's fine because it can run over the same Ethernet network. It just won't have the benefit of RDMA, very low latency. Okay. So what does this enable us to do? This enables us to use the same Ethernet network for the front end and the back end connectivity, but still to have the very low latency RDMA based transfer, and it allows us to take our agility, our ability to scale to new levels, so to disaggregate the architecture and make it even more flexible, so adding individual extra units, no longer having any restrictions implied by having the SAS layer in the infrastructure, and we can scale this by adding more and more hosts, more and more JBOF. So JBOF might be a new term to some of you, so just a bunch of flash in the NVMe fabric connectivity, and it can do other things about how we scale. You no longer have to have pairs, you can be more agile, adding individual controllers all into the same fabric. And I think perhaps the best thing at this point is to show you, show you what the solution looked like, what this enables in the demo.
Just maybe before that,
Yeah.
what does this architecture do for things like failure domains and repair time? So if something fails and has to be replaced,
Yeah.
what about rebuild times?
It gives
That's
you,
a great
gives you
question.
different options.
Yeah, a lot of options. A lot of options. We'll talk about that in the demo. But you might want to show.
This one?
No, the other one.
That one?
Yeah. No. No. Yeah, just go on. Just go.
Okay,
Yeah.
so today we have the K2. and we've gone into some detail about how it looks today, and it's doing very well and competing very well with our competitors, and it provides very good scalability and adaptive block size and scale out. But we can expand that by what we're calling Omega, which we're not making any product, to be very clear, we're not making any product announcements today. This is the future direction or vision of the product, but it's what we're working on actively, and it increases the operational simplicity, and it increases the options we have around the scale between the different namespaces of deployments that we have, and it gives us a significant improvement in utilization layers, and it allows you to change things dynamically on demand. I think that's probably, no, yeah. I just want to show you what it looks like if you're one of our large customers that's deploying large pools of Kaminario systems. So today we're selling you separate arrays. They get racked up and they're discrete units, and you can expand them and they can grow, and potentially you can shrink them and they can reduce, but it's requires planning and it requires additional purchasing, and it's not on the fly. But if you look at how this compares with the future architecture, you can buy a pool of disaggregated storage capacity and compute and utilize those as you see fit, and you can even orchestrate how they're utilized, and it can change very dynamically into different we call them virtual private arrays to match your requirements as they change.